Okay. So you can just assume that today's class will be a foundation class. సో ఇప్పుడు ఈ ఫౌండేషన్ మనకి కొంచెం బేసిక్స్ క్లారిటీగా ఉంటే యూ కెన్ మూవ్ ఫర్దర్ అండ్ కెన్ ఈవెన్ ఏబుల్ టు అండర్స్టాండ్ ఫర్దర్ టర్మ్స్. ఓకే. సో ఫస్ట్ థింగ్ ఈజ్ మెయిన్ థింగ్ ఏంటంటే విల్ బి ఇన్ ద నెక్స్ట్ కమింగ్ క్లాసెస్ విల్ బి వర్కింగ్ ఆన్ డాకర్ ఇంజన్ అండ్ కంటైనర్స్. సో బిఫోర్ గోయింగ్ టు that we should exactly understand what is this docker, what is this containers, and what are all these DevOps concepts, what are all will come under development, and what comes under operations, and what are exactly the problems which people have faced in the previous models. So why DevOps is becoming very popular. So how DevOps is giving you solutions in solving real time problems. So what are the benefits and advantages of these containers or dockers. So what are these docker images, what is this docker hub. So how to implement, how exactly does it work, what will be the architecture of it. సో దానికోసం ఏంటి అంటే ఫౌండేషన్ విల్ ట్రై టు డిస్కస్. సో మోస్ట్లీ ఐ విల్ బి ట్రయింగ్ టు టెల్ యూ యాజ్ బేసిక్ యాజ్ పాసిబుల్. So the easy way to understand any concept is first you need to identify the problem. Okay. So what exactly was the problem and how these guys are able to fix the problem. So that is how the technology will be evolving, right? So there will be some problems and someone will be coming with a solution. Okay. If that solution is working, everybody will start using that solution only. So that is how it will be done. So first thing is before going to this server and all, first we'll just try to understand our basics. So how exactly our operating system works. Okay. So first we'll try to understand that, and then we'll start with server. So mostly ఏంటి అంటే one thing I'll tell you guys. So this you won't consider as class, just we will make it like a discussion. Okay. The more you discuss this topic, the more points you'll try to understand. So I'll also try to give you mostly relevant examples. So relevant examples so you can just catch up the concept. But I need you guys to discuss this topic today. Okay. సో మీరు కూడా మీ పాయింట్స్ మాట్లాడి తెలిసింది చెప్పండి, రాంగ్ అయినా ప్రాబ్లం లేదు, ఈవెన్ ఇఫ్ ఇట్ ఈస్ రాంగ్ నో ప్రాబ్లం. సో ట్రై టు డిస్కస్. ఓకే. సో ఫస్ట్ థింగ్ ఈస్, హ్యావ్ యూ guys ever heard about SDLC అనే వర్డ్ విన్నారా?
Yes, sir.
ఓకే. వాట్ ఈస్ SDLC అమ్మా?
Software development lifecycle.
ఓకే. వెరీ గుడ్. సో వై వి యూజ్ దిస్ SDLC? యూజ్ ఏంటి?
Uh, process
ఓకే.
trying to
ప్రాసెస్.
ఒక వర్క్ trying to ఒక సాఫ్ట్వేర్ కంపెనీ వచ్చి వర్క్ అడిగితే లైక్ కోడింగ్ ఉంటుంది, దాంట్లో టెస్టింగ్, డిప్లాయ్మెంట్,
ఓకే.
డిజైన్,
సో
డిజైన్ ప్రాసెస్
కరెక్ట్, ఆ స్టేజెస్ అంటారు అవి. కరెక్టా?
తెలుసు.
ఓకే. ఏమేమి స్టేజెస్ ఉంటాయి మనకి?
బిజినెస్ రిక్వైర్మెంట్,
రిక్వైర్మెంట్స్, వెరీ గుడ్. రిక్వైర్మెంట్,
డిజైన్,
డిజైన్,
కోడింగ్,
కోడింగ్ అనొచ్చు, డెవలప్మెంట్ అనొచ్చు.
టెస్టింగ్.
కోడింగ్, టెస్టింగ్, ఇంకా టెస్టింగ్ తర్వాత రిలీజ్ చేయాలి కదా. ప్లానింగ్ ఎక్కడ వస్తుంది?
ఫస్ట్ రన్ డిజైన్
డిజైన్‌కి ముందొస్తుందా? డిజైన్ తర్వాత వస్తుందా?
డిజైన్
డిజైన్
తర్వాత వస్తుంది సార్.
ప్లానింగ్
డిజైన్
తర్వాత
ముందు
డిజైన్ వస్తుంది. Okay. So very good. I think you got some idea about this. Okay. So every software, if you need to develop, we need to follow these steps. Okay. So ఇంకా మీకు సింపుల్గా చెప్పాలి అంటే సో SDLC. So in simple terms, I think you can consider this one. Okay. So one, two, three, four, five, six steps. Okay. So in the first step, we will plan. Second step, we'll do analysis. Third step, we'll design. Fourth step, implementation. Fifth step, testing and integration. Sixth step, మెయింటెనెన్స్. మనం ఈ మెయింటెనెన్స్ ఒకటి మిస్ చేసాం అనుకుంటా. రిలీజ్ చేసిన తర్వాత మళ్ళీ మెయింటెనెన్స్. ఓకే. సో ఇది నార్మల్గా మీకు ఇంటర్వ్యూలో వెళ్ళినా కూడా ఈ క్వశ్చన్ అడుగుతారు జనరల్గా. సో ఎనీ సాఫ్ట్వేర్ ఇఫ్ యూ వాంట్ టు డెవలప్ విల్ ఫాలో దిస్ మెథడాలజీ. సో ఎస్డిఎల్సి అనేది మనం ఒక మెథడాలజీ అని అనుకోవచ్చు. సో ఈ ఎస్డిఎల్సి మెథడాలజీలో ఒక సాఫ్ట్వేర్ మనం హౌ యూ కెన్ డెవలప్ ఏ సాఫ్ట్వేర్ అనేది ఈ ప్రాసెస్లో ఫాలో అవుతాం. సో దీస్ ఆర్ ఆల్ ద స్టెప్స్ విచ్ వి ఫాలో. ఫస్ట్ we will take the requirements from the client, like what exactly the client's problem is. Okay. And what he is expecting, so how we can address the problem. So first we'll gather all the requirements from the client. Okay. So then we'll do the planning part. So planning అంటే దాన్ని ఎలా చేయొచ్చు, how we can address the issue. So so what you can do, so planning until you can say it's like which platform can I use, which programming language we can use, which software we can help. So these are all basics which are required for the development of your software will be planned. Okay. So then it will come to design part, so how the user interface should be appear. Okay. So regarding this design part, it will be there. So after the design, the development will be done, the programming part will be done. So after programming, it will go for the testing phase, how it is working, is if it is having any errors while operation. So all this testing will be done. So then release. So then the after testing is done, so testing is a repetitive process. If it is finding any problems, then again it will go back to the development or coding team. Again this development or coding team will fix the problem. Again it will send it to the testing team. Again the testing team will do the testing. If they find any fault, it will send back to the development team. So that is a continuous process. So after that, if mostly all of the testing is done, if they're confident that there are very least number of errors, then they'll do release it to the client. Okay. So release is nothing but release, we can also call it as release or production. Okay. So this will be the final thing which will be submitted to the client. Okay. So after that, the client will be start using the software. So while using the software also, there might be some problems. So that time you need to give maintenance. So maintenance will be optional. Some clients will take the maintenance part, and some clients will not take the maintenance part. Okay. So this is basic, I think this is very very basic, which I think most of you already know. So this is the process which most of the companies will follow for the development of the software. Okay. So this is fine. But where exactly we are, like we are now working on this AWS. So how can we, how can this help us? So we'll try to get into real time scenario and try to understand where exactly the problem is coming. Okay. So I think we'll take one paint. Okay. Paint will take. Okay. So here what we have done, so you can just consider divide these into two sections. Okay. So what you can do is, One is these I think these all these sections, this planning, design and development is there, right? So it will be coming under one section because everything will be done in the software office, right? So this is one section where the developers and designers will work together and they will be building the software. So basically you can also call it as a build or develop section, right? So after this there will be another section where it will be going to the testing, right? So after this is release, production and maintenance. So just I'm just for your understanding purpose, I'm taking it to this three categories. One is this planning, design and development as one section, testing is one section, release in production is one section, for your understanding. So right now we are just telling that we are learning DevOps, right? So I think this is also not correct. Save and sketch. This is also not. Where it has gone. Okay, we'll continue with this notepad only. Okay. So we are just telling that we are working on DevOps. So I'll say development, okay, and I'll say operations. Okay, so operation development. So just I'm telling written is in a short term shortcut. DV stands for development, whereas OPS stands for operations. Now you might be asking, sir, what exactly is this development and what are these operations, right? So that is why, for your understanding, I have told that it is categorized, right? So in this development section, we'll have this development of your operation, development of your product or software. So in the development section, what these will be included? So planning, designing, development, and coding. And we can simply say that a group of developers and a group of designers will be building your software. Okay, so this is one section where all the developers or designers they'll be working and they will be building one software. Okay, so that will be coming under this development. Okay, similarly now I'm saying this operations, right? So operation means these people have developed one software, for example. So this part developers have designed one software and the testing team they have done the testing and they have fixed the errors, then they have prepared one finished software. Okay, we'll see in our simple terms we can say they have developed one finished product, right? So now that finished product need to be sent to the client, right? So that then only we can then only people can use the software, right? So this will come under this operations section. Okay, so simply in very basic terms we can also call it as deployment, right? So deployment means the I think what we have done, I think I can just correlate with small example. We have created our instance, we have hosted our website, right? We hosting the website will fall under deployment, right? So as you know that the whole HTML website is already got designed So we got the final product, right? So final product is nothing but the project you have received. So that project need to be hosted. So hosting is nothing but it will be coming under this deployment, right? So that will be coming under this operations. Okay, so this release and maintenance will be falling under this operation. So you might be asking, sir, where we will be working on. Okay, so you will be working mostly on to this operations section, right? So you will be mostly concerned about the deployment of your software. Okay, so mostly the DevOps people who are learning DevOps, mostly they will be falling under this operation section and mostly involved in the deployment. Okay, so in the deployment there are so many tools and things you need to understand, but we'll try to understand in a very very easy way. Okay, I'll try to give as many as examples for you, right? So so what will be in this operations, what will be this production, what will be this staging, what will be the operations in between, how you communicate with the testing team. So where you will be in between you will be having this version control, source control. So where you will be using git. So many tools will be there. So before that we'll try to understand how exactly, why we exactly need this DevOps. So previously, there is nothing like DevOps. Only this all the things used to be maintained by very few people. Even the developers only used to deploy the software. Okay, so there was no need for DevOps, as there is as you know, the websites are increasing rapidly, and there are a huge number of traffic coming and needing the our data. So only developers or this designers won't be able to manage the software, because they are very much concerned about the problems and fixing the errors. Okay, so that is the reason why they have fixed the separate people for maintaining these tasks, especially deployment, release, or production or maintenance part. Especially people were recruited. So for those people they are training it as DevOps, and they are employing them. Okay, so this DevOps people need to have the complete knowledge of the whole process, right? So that is the reason I have told you. So this is the complete life cycle. So just you need to have in your mind, like, okay, this is the sequence of steps which will be happening. So that is the reason I have told you. So you need to just explore much and much more about this SDLC. I think there are very some big topics only. If we can't discuss this in detail, so just you watch few videos on YouTube which are relevant to SDLC. Okay, so then coming back to our DevOps, first we'll try to understand what exactly it used to happen. Okay, so we are discussing about so many servers, right? So we have created instances. So how this server will exactly work? So that we'll try to understand. Okay. So for your simple understanding right now, you can just keep in mind. So what you can do is just development. This three steps you can just remember. One is I think we can take notepad also. Three things we'll try to understand much better now. So development. So once the product is developed, then we'll go for testing. Once the testing is passed, then it will go for production. Production, or you can also say it as release, right? So as you know, there are three teams involved. Okay, one team will be working on development, and one team will be working on testing, and one team will be working on production, right? So three teams are working. Okay, as you know, the main software will be starting from development team, right? So development team, they will develop the software for you. So what happens, they will develop the software. So what happens, each software will have so many dependencies. Okay, for example, if you are working on building some software, so you need to be having using programming language. Just for your understanding I'm telling, so we need to have programming language, right? Similarly, need to have libraries, right? Similarly, we'll have so many dependencies, right? So dependencies might be so many, like we can say php or python or database, right? So some other things, javascript, xml, json. So these might be of so many dependencies, right? So what happens is, as you know, this software need to be traveling from multiple places. So from this is team 1, from development team it need to reach testing team. From testing team they have to perform the testing, and after that if the testing get passed, then it will be going to the production, right? So what happens is, in this journey, what happens is, for example, this is there, development team is there. In a simple terms, you can tell, I think everybody is very familiar about pubg, right? So for example, these people are developing this pubg software. So as you know, pubg is a very huge program. It will be needing so many dependencies and libraries to be working. Okay, so what this person will do is, this development team, they will build one package. So for example, I will say some 2 GB of package, and then they will shift this 2 GB of package to the testing team, right? So after sending to the testing team, sometimes what not sometimes, most of the time what happens is, it works very well in the developers laptop, but it won't be working well on testing laptop. Okay, there might be so many errors. Sometimes even for you also, most of the time it might happen. You will be downloading one big software from the internet, and when you install on your laptop, it might not be working. So for that there might be so many reasons. So reasons might be some you'll get some errors, right? So sometimes it will say missing files, right? So there might be so many other things, like missing dll. Sometimes we'll say configuration is missing, and sometimes it will say outdated. Okay, sometimes it will say needs update. Sometimes you'll see version compatibility. There are some of the problems, but there will, in real time there will be more number of problems, right? So while shipping this product from development team to the testing team, so in the developers perspective, everything is working perfectly. But when it comes to the testing computer, so in the testing computer there are so many problems, right? So you need to fix all this again. If this testing team will go and inform the developer, right, sir, what our your software is not working properly. But what the developer will say, sir, everything is working properly on my computer, and why it is not working on your computer, right? So they will try to fix this problem. Okay, so mostly what happens, for example, in simple way I'll say, for example, we are using some dependencies. So dependencies, I'll say I'm using php 4.5. Okay, so the thing is, testing team should also have this php 4.5. For example, here the for example, if a testing team is using this older version, for example, I will say they are using php 3.5. Sometimes what happens is, this 4.5 will have new features. The developers might have added new features, whereas the new features will not run on this testing team. Why? Because the person is not using updated software. So what happens is, when you're building a very big software like PUBG, there will be some hundreds of dependencies, right? So hundreds of dependencies, what happens? You can't keep check of everything. So if one or two we can easily identify. So I'll say here we'll use hundreds of dependencies, right? So that time what happens? You won't be able to find the problem, right? Am I correct? Are you guys getting me?
Yes, sir.
Are you guys able to get me? ఎందుకంటే because I'm trying to able to explain the concept. And if you're not able to get it, please మధ్యలో అడగండి. Yeah, Vamshi, tell me. Vamshi Surya Sai, do you have any
Yes, sir.
question?
No,
Are you
sir.
having any doubt? Okay. So there will be so many hundreds of dependencies. That time we might not be able to identify the exact problem, right? So what happens is, so the software package which is coming from the development team should be working exactly the same in the testing team also. Okay, so you need to make this happen in a very smoother manner, right? So there should be no problems while shipping your package from one team to another team. So after this also, if even though if it is working on this testing team, there might be cases that it might be not be working in the release or production phase. Again, you can say there might be so many other problems. I have found out there will be some problems in dependencies. Again, what happens is you need to install so many applications, right? What you need to, for example, I'll say I need to install Java, I need to install PHP, I need to install JavaScript, I need to install Node, I need to install React, I need to install this Python, I need to install .NET framework, right? So there will be so many things which are involved. Okay, so every time what happens is, as we are using this so many dependencies, so these people also need to configure their computer in a similar manner, then only it will happen. So again, this configuration part will be missing. So development team will say this is working on my computer, testing team will say it is not working on my computer. If sometimes it is working well on testing team, then the production people will say that is not working on the final release. Okay, so for this what happens is we need to make one smoother journey. Okay, so it need to be smooth to all these people. Okay, shipping the code from one place to other place need not face any problems, right? So that is the responsibility of this DevOps team. Okay, so to make this in a very easy manner, first we need to understand this concept called virtualization first. Okay, so I'll say virtualization, or else simply I'll say virtual. So virtual, I think you might be uh, heard this term many times. In a very simple terms I can tell, the thing is not real, but it acts as a real thing. I'll tell one very simple example. We are in the class, right? So I'm not sitting right in front of you and teaching the class, but you are able to feel my essence, like you are able to hear my voice, even though I am not sitting in person with you, right? In the same way, we are working on AWS, right? So in AWS, what is happening? We are able to create our servers, we are able to create our instances, were able to install our softwares, we are able to host our websites. But actually what happening is, all these instances are not right in front of you physically, right? You might not be able to see the servers physically, but the thing is they are doing the actual job for you, right? So that will be that we can call it as virtual. The thing is not physically present, but it is doing at the actual job for you. Okay, so this virtualization, first you need to understand. uh, I think have you guys heard about this software called VMware? VMware అనే సాఫ్ట్వేర్ ఎప్పుడైనా విన్నారా?
No,
VMware
sir.
VMware అనే సాఫ్ట్వేర్ విన్నారా? సో వాట్ ఎగ్జాక్ట్లీ ఇస్ దిస్ VMware?
స్ప్లిట్ చేస్తుంది సార్. అంటే ఒక కాన్ఫిగరేషన్‌ని పార్ట్స్ కింద డివైడ్ చేస్తుంది సార్ అది. కంటైనర్స్ టైప్.
ఆహా! కాదు. సింపుల్ టర్మ్స్‌లో చెప్పండి. టెక్నికల్‌గా వద్దు. టెక్నికల్‌గా అవసరం లేదు.
VM virtual machine.
ఓకే. VM అంటే వర్చువల్ మెషిన్ కరెక్ట్.
Is it like terminal, sir? Linux.
ఆహా! కాదమ్మా. So I'll take one computer, okay? So I'll take one computer. So this is my hardware. Okay, hardware అంటే మన CPU. It might be having some ఒక 8 GB of RAM or 4 core processor and 1 TB of storage అనుకుందాం. Okay, so this is my hardware. ఇక్కడ I think in Google Meet will be having some software. We'll see. Okay, whiteboard is there. Okay. Okay, on this we can work. So basically, just I'll be putting different levels here. So for example, I'll say hardware layer. Okay. So you'll buy one computer which will be having some hardware. For example, I'll say 16 GB RAM, 4 core processor, and I'll say 1 TB hard disk. Okay, so this I'll do. Okay, so then what you'll do is after this purchasing this hardware, you'll be installing one operating system, right? So you need one operating system. I'll say for example Windows. Okay, I'm working on Windows operating system, right? So after this what happens is, so we'll be installing one VMware software. Okay, so VMware software na name ante we can also call it as a hypervisor అని అంటారు అన్నమాట. సో సిమిలర్లీ హైపర్వైజర్ ఇస్ ఇప్పుడు ఐ థింక్ వెన్ ఐ క్లియర్లీ గివ్ ఎన్ ఎగ్జాంపుల్ దెన్ యూ విల్ బి ఏబుల్ టు అండర్స్టాండ్ ఇట్ ప్రాక్టికలీ. సో హైపర్వైజర్ అనేది ఇన్స్టాల్ చేస్తాం అనుకుందాం ఫర్ ఎగ్జాంపుల్. సో హైపర్వైజర్లో ఏంటి అంటే ఐ విల్ సే హైపర్వైజర్ ఇస్ నథింగ్ బట్ VMware సాఫ్ట్వేర్. ఓకే, so using this VMware or hyperware software, we'll be able to share the resources of this system. Okay, so for example, I'm using this Windows operating system. Okay, so what happens is here I can create multiple virtual machines. Okay, so I'll call it as VM1, virtual machine 1. So similarly, I'll create one more. I'll say virtual machine 2. Okay, similarly I'll say virtual machine 3. Okay, so here what I'm trying to do is, so one second, I'll complete this also. VM3. Okay, so I have taken one computer. So I have taken my computer with this hardware resource, 16 GB RAM, 4 core CPU, and 1 TB of hard disk, and I have installed Windows operating system. Okay, so then what I'm using this, I'm using a software called VMware, which is an hypervisor. So what this hypervisor will do is it will share this hardware resource with this VM. For example, this VM1 is there. Inside this VM1, what I have done, I have installed one OS, Linux operating system. Then I have shared some 4 GB of RAM. Okay, then I'll install some 250 GB of storage. Okay, so what I'm trying to do here is I'm splitting the hardware resource. Okay, so this from this 16 GB storage, what I'm trying to do is I'm taking this 4 GB storage and I'm installing one separate operating system. Okay, so here this is one system. So this is system number 2, system number 3, system number 4. Okay, in this way we can share our resources. So hypervisor is is the thing which will be doing this task for us. Using this hypervisor, you can share the hardware resources and build multiple number of tiny virtual machines. Okay, so now you can see is, as you know this, we are having only Windows operating system, right? So inside this Windows operating system we'll be able to work on Linux operating system. So similarly in the second and third also we can do the same. I can also install some Linux or Red Hat operating system or some open source operating system. I can get the same operating system feeling, which is actually not real. Okay, so this is how I'll be doing. So now you might be asking, sir, why we are needing this thing, right? So first thing is, what happens is this all started in this way. As you know, we have discussed this. So while working this while shipping our software to multiple people, so we were having errors. So this virtual VMware or hypervisor software used to fix our problem. So you might be observing that. So we are working on this AWS, right? So AWS, we are able to create instance, right? So same, you can just correlate this example to this. Okay, so I think we have discussed about data center. So we have told that in data center there are several lakhs of servers together forming into one single computer. So I'll say, in one for example, this AWS is there. So AWS we are creating instance. Okay, so for example, AWS will have one huge computer. Okay, so I'll say one for example, I'll say this is for example 128 GB of RAM. One instance AWS will be creating. Okay, on this what happening is, so we are going and asking AWS to create one instance, right? So we are creating this T2.micro, right? So T2.micro, we are getting 1 GB of storage, sorry, 1 GB of RAM and one CPU, right? So what happens is, this is AWS, you consider. So AWS, we are asking it to create one server. So what this AWS is doing, so it is creating one virtual machine, so which will have 1 GB RAM and one CPU. Okay, so in this way, what is happening is, so AWS is able to share the hardware resource and will be able to provide you multiple number of instances. So yesterday we were working on 4 servers, 4 VMs. So these 4 VMs commonly share the all the hardware resources from the main server. So basically this we can also call it as host operating system. Host operating system we can say, or you can also call this as host hardware. Okay, so this person is providing us all the resources, right? So this will be the host. So these people, we are using the operating, the host is providing us all the resources and these virtual machines are using the resources. Okay, so this is fine. So this is how they were able to fix the problem. They're taking one big computer and they are splitting it into small micro computers, right? So what happens is, how this problem got solved is the question, right? So the thing is, we have worked on snapshot, right? So we have taken snapshot of instance. So snapshot of instance, what we have done, So we have so snapshots we have taken. So snapshot we have done for volume and instance. Okay, so for instance, what we have done, so we have taken image, right. So using this image, again we have created new VM, right. So in the same way, this virtual machine also they have done the same process. So what they have done is the developer will be working on this one single virtual machine. Okay, so in this single virtual machine, what the person will do is he will be creating one image. Okay, so that image will be inclusive of all the complete test environment of the developer. Okay, for example, the development team, they are working on one computer. I'll say development computer, development PC, I will say. Okay, so this development PC, what I can do is I can create one image. Okay, so we'll send the same image to send image to testing team. So what happens if we're sending the same image to the testing team? Now do you think there will be any problems? Because all the things which are required, for example, the copy of the development team's computer will be given to the testing team. Okay, so what the person will do is, instead of sharing the software, so previously what the person is doing, he used to share the project. So the project, again you need to provide the environment, you need to install all the dependencies, then only then only it will be working. So what we have found out, so while installing this, there are so many problems. We are identifying that so version problems are coming. So similarly, some resources won't be there. So these are all different problems which we were facing. Missing files or missing DLL configuration, sometime outdated, sometime we need version compatibility. So many problems were coming, right. So what the developers have done is, so they have taken the image of their virtual machine and they passed the same to the testing. For example, I'll say image 1. So again what they'll do, again the testing team also will run the same image 1. Okay, so what happens is, all the configuration of of this image 1 will be same as image 1, right. So both will be same. So if both are same, then there will be very less number of problems. Whatever the development team is getting on their computer, same thing will be getting in the testing team also. So there might be no changes in this, correct. So whatever the copy of this VM, so for example, the same copy is given to the testing team. So the testing team will also get the same image, such that we can resolve all these problems, right. So this is one way they have tried to fix it. Again, again, if both are working on image 1, so both the image are working one. So they are here, they'll test and identify the problems, and they will inform it to the development team. So again the team will fix. And again what they will do, after fixing, what they will do, they'll send image number 2. So again the same image will be sent to the testing team. So now again, so they will getting the same dependencies, same libraries, same configuration, everything on testing team also. So this is how they were able to fix the problem. Okay, so this is how they were doing. So again, this problem got solved using this hypervisor. So what this hypervisor will do is, by hypervisor or any VMware software, it will install the VM image on your local computer. Okay, on your local computer, what we can do is, you can get the image from the development team, and you can install the image on your system, right. సో ఇది క్లియర్ కదమ్మా, ఇమేజెస్తో సాల్వ్ చేశారు ఫస్ట్. సో దిస్ ఇస్ హౌ దే వర్ ట్రయింగ్ టు ఫిక్స్. ఓకే, సో నౌ వాట్ ఈస్, నౌ వీల్ అండర్స్టాండ్ వాట్ ఎగ్జాక్ట్లీ ఆర్ ద ప్రాబ్లమ్స్ విత్ VMware. So okay, so hypervisor use చేసుకొని again if we thought that it is the smoother journey if we are shifting one image to the next team. Okay, sharing the image, it was the one of the solution we found out. Okay, now again sharing the image is also not a complete solution. Okay, so so as you can see, I'll tell you what exactly is the problem with this VMware, okay, or hypervisor. So for example, I'll say I'll take it as I'll tell this is as for example 16 GB of RAM. Okay, so using the 16 GB of RAM, or else I'll take 12 GB of RAM. I'll take, okay. So 12 GB of RAM. So what happens here is, so we can use, so here we can use 4 GB. So here you can use 4 GB. So here you can use 4 GB. Okay. So while creating the image, this virtual machine will directly share the hardware. Okay. So this 12 GB will be split into these three computers. That means VM1 will take 4 GB, VM2 will take 4 GB, and VM3 will take 4 GB. Okay, so this is nothing but fixed, so we can't make any changes. For example, this server is there, VM1 is there, it is running. Suddenly the traffic is growing. So what we cannot do is, we cannot change this configuration to 6 GB or 8 GB, right? So this is a fixed number. Why? Because this is working on hardware level. Okay, so VMware or hypervisor will be working on hardware level. So what happens is, this hardware which is there, this is fixed. If we are creating one virtual machine for with 4 GB, that 4 GB virtual machine is fixed. We won't be able to change in the during the runtime. Why? Because it is a hardware level virtualization. Okay, so that means once you are providing this hardware, you cannot change any hardware. Okay, so if you are giving 4 GB, that 4 GB is fixed, you can't make it 6 GB. And later you can reduce this to 2 GB. Maybe this we 8 plus 6 is equal to 14, right? So this figure, if during the runtime we can't reduce the hardware of this, and we can share this hardware to this person. Okay, so will be fixed. So that was the biggest problem where people facing. Once you are providing this VM or creating one VM, so this is what the fixed problem is. Okay, and again, even though if you are giving this 4 GB of RAM, for example, here this Windows operating system we are running, so Windows operating system will at least consume 1 GB of RAM. Again what happens, so again in this VM machine, for example, I am installing Windows operating system. Okay, I'll say Windows. So again what happens, so here I'll install Windows VM1, again I'll install Windows VM2, again I'll install Windows VM3. So as you know that we are working on three VMs. Okay, so what you need to have, as you know, all this for installing this Windows server, we need to have we need to buy licenses. So again we need to purchase three licenses here, three Windows licenses, that will be costing you some X amount. So this is again and also problem is, cannot change hardware. So once you are giving 4 GB, that 4 GB is fixed. And again, wastage of huge resources. So you might be asking, sir, how it will be wasting the resources? So here you can see already, for example, I'm having this 12 GB of RAM. So this 12 GB of RAM, I'm splitting 4 with these guys. So as you practically see that, so this operating system also need one some RAM to run. Out of 12 GB, 2 GB RAM will be consumed by this operating system, right? So you'll be having only 10 GB of RAM. So 10 GB of RAM, for example, I'll say this I'm taking 5 GB of RAM. So again, I'll say now only I'll have to split 2.5, 2.5. Okay, so here 2 GB has been taken by this operating system. So that is why we are having only 10 GB of RAM. So that out of 10 GB of RAM, VM1 I'm given 5 GB, remaining 2.5, 2.5 I'm giving to VM number 2 and VM number 3. So again, this VM it won't get the complete 5 GB of storage, right? So here what happens is, again we need OS. So OS will take at least 1 GB, roughly we are taking. So 1 GB will be taken by the OS itself, right? So again, you might be seeing, even if you are giving this 2.5 GB, again OS will be taking 1 GB, right? So remaining only 1 GB is there. As you can see, 2 GB lost here, 1 GB lost here, and 1 GB lost here. And also here, if you install here also, the 1 GB will be getting lost. So totally 1, 2, 3, 3 GB plus 2 GB. So here you can see 5 GB of hardware is getting unnecessarily wasted. Okay, so this is the main problem which people were facing when working on virtual machines. So unnecessarily we are wasting our hardware resources. So did you guys able to understand this concept?
Yes, sir.
So I'm just trying to I'm asking you guys to imagine the real time problems, so how we were able to solve the existing problem. Okay, so this was the problem where people were facing. Okay, so unnecessarily we are spoiling so much of hardware resources unnecessarily. 1 GB of RAM wasting here, wasting here, wasting here. And again, what we need to do is, as the more number of VMs we are creating, the more number of licenses we need. As you know, Windows operating system is a license will be given according to the system, right? So here we are making three systems. That means you need to purchase three license. Okay, it doesn't mean only operating system. You'll have to purchase other licenses also. For example, databases licenses also, some security licenses also, some antivirus licenses also. In that way also you are increasing your charges. Okay, so images also, because what happens is this images, for example, this is one developer's computer, so he is working on VM1. He has created one image. So again, this image need to be installed on the testing team. So tester will also have one computer. So inside his computer we will be installing this VM. Again, to install on this extra computer, he need license, right? In the same way, it will this same VM image will go to the release computer. So again, release computer also he need to install. So again, installing there you need to have license, right? So in this way, multiple teams are taking multiple things. Okay, even though the problem is getting solved from the software level, maybe this bugs, errors, version control, everything we are able to fix, but still we are having more and more problems to address, right? So mostly in in this thing, we were sharing the VM images. Okay, try to remember that only. Okay, so next after this, we'll just try to understand how they are able to fix this. So I think, can we duplicate this? Duplicate, or else I'll come, click on control. Okay, this I'll save first. Okay, okay. There is one more option. Make a copy. Okay. So now we'll try to understand how we are able to fix this. Okay, so they have started with this new concept called as containers. Okay, so containers might be a new concept for you. Okay, so simply right now, because as you are in a very beginner level, I will say just assume that a container is also like a virtual machine only. Okay, but not exactly a virtual machine. It does a job like a virtual machine only. Okay, so with using this containers concept, so these problems were able to solve. Okay, so one important thing which you need to understand here is, using this VMware, it is hardware level virtualization. Okay, so that means this VM will be sharing the resources directly through the hardware. Once you are fixing, for example, if you are fixing this 5 GB RAM as my VM, this 5 GB will be taken directly from the hardware. Okay, so RAM, that means out of 12 GB RAM, 5 GB RAM will be directly shared with the VM1. Okay, so whereas in containers the concept is different. Okay, so in what happens is, this hypervisor is there. So similarly, instead of this VMware, so what happened is, one company came forward and they have created one engine called as Docker engine. Okay, so you might be asking, so what exactly is Docker engine? So simply understand this: Docker is a company. They have developed one software similar to VMware. So with this, using this Docker engine, we will be able to create containers, right? So in VMware, we were calling it as, what we are calling? We are calling it as virtual machines, right? So here, when you are creating this Docker engine, using this Docker engine, we will be able to create containers. Okay, so simply just for your understanding purpose, just note it as containers only. So this is container. So I'll duplicate container, container. Okay, right? So here what this Docker engine will do is, so the Docker engine will create containers instead of virtual machines. Okay, so now I'll say, as we are having this 12 GB of RAM here. Okay, so out of this 12 GB of RAM, for example, I will say, so this container, it's taking, I'm giving 4 GB. Okay, for this container I'm giving 4 GB. Again, this container I'm giving 4 GB. Okay, 4 3 ja 12 GB, I got it. Okay, so now again we'll come back to the same scenario. So here what happens in this, what happens is, this 12 GB of RAM, it is fixed. If you are giving 5 GB, the 5 GB of RAM is fixed to this. Okay, so whereas Docker came forward with new concept. Okay, so these people have came with new concept. So here we are calling it as hardware level virtualization. That means we are sharing our hardware directly to the VM. So here what this Docker is doing is, it is sharing the resources from the host operating system. Okay, so it will that means these containers will run from through software. That means we can say uh, software level virtualization. Okay, so I'll write that also. That is one important point. So software level virtualization. So why I'm calling it as level virtualization is, for example, we are having this hardware 12 GB RAM. So using this 12 GB RAM, we have installed one Windows operating system. So as you know, this uh, this Windows operating system will completely have the control over this 12 GB of RAM, right? So in the same way, I'll tell you one very simple example. So for example, if you go to this task manager, so here you can see, for example, these are all the different processes which are running, right? So that means, as you can see, the memory is 63%. 63%, I think, in much more details, I think, regarding this. Okay, we'll go to this memory. Okay, so this is nothing but software level virtualization. So as you can see, I'm having 8 GB of RAM. Out of 8 GB of RAM, 7.9 will be usable. Okay, so 63% is available for free. So what happens is, this much is available. For example, here what happens is, exactly with this software for level virtualization is, for example, I'm running Chrome. Okay, Chrome application I'm running, so I need lot of hardware resource. Okay, as you can see, uh, where while Chrome is running, so Google Chrome, or else I'll take this one, CPU. Okay, so as you can see, Chrome is running out of almost 1 GB of memory is consumed by this Chrome applications, right? So what happens in this, containers also work on the same concept. So here you can see the number of processes. In the same way, you can consider these processes as containers. Okay, so practically telling, for example, 12 GB of RAM is there. Okay, so for example, this 4 GB of RAM I have created. So what happens is, all the time these two containers will not be using 4 GB of RAM completely. Okay, for example, this container 2 is there. So container 2 is consuming only 1 GB of RAM, for example. Okay, so what happens is, remaining 3 GB is available for free. So that 3 GB you can allocate to this one, 4 GB plus 2 GB. Okay, so why? Because this is happening because we are using software level virtualization. So that all the management will be done using this Docker engine. Okay, you will install this Docker engine. This Docker engine will take the resources from the host operating system instead of the hardware. Okay, so this Docker engine will not touch the hardware. So this Docker engine will only touch your operating system. So if your operating system says that, if I'm having only 5 GB of RAM, okay, so it will consume only that 5 GB of RAM, and it will split between these computers, between these containers according to the priority. So here there is no fixed level of RAM. Okay, even if you say, if you, this container require more RAM, so Docker engine will try to give the extra RAM which is required. Or else, if the container is consuming very less RAM, for example 1 GB RAM is only sufficient, so it will provide only 1 GB of RAM. Okay, so if only this, for example, all the containers are running with only 1 GB of RAM only. That means only 3 GB of RAM is consumed. Rest of the RAM will be available for free. So suddenly this container need more RAM. So suddenly the computer, this container is asking for 4 GB of RAM. So the Docker engine will make sure that it will be provided with the 4 GB of RAM. Whereas the in the concept of this VMware, or VMware concept, so this is hardware level virtualization. Once you are creating this VM1, so if you are creating virtual machine with the 5 GB of RAM, that 5 GB of RAM is fixed. You cannot share this resource with VM2 or VM3, or even with the host operating system. Okay, why? Because this is 5 GB of RAM is taken directly from the hardware. Okay, so here it is not happening. Why? Because this Docker engine is made in such a way that it will only utilize the software. So it will ask the Windows operating system, so how much RAM is available with you. If the Windows operating system will say, sir, I am having 5 GB of RAM, so this 5 GB of RAM it will take, and it will split among the containers. If it is having requirement for only 3 GB, so it will take only 3 GB of RAM, and the rest of 2 GB will be given back to the operating system. It will say, Docker engine will say, sir, I have only 3 GB of requirement. If you are having this 2 GB of RAM, please keep it by yourself. If when I'm having some need, I will take that extra 2 GB of RAM. Again, what happens is it will also make sure that these containers need to be running in a stable way. Okay, so if this container is there, this container will suddenly there is need of more RAM, so it will provide. So it will provide if the container is asking for more RAM. For example, it is having more traffic or more applications. If says, sir, I need 2 GB of RAM, it will provide 2 GB of RAM. So how can it get? So because it will take the control of this resources through the operating system. Okay, so this is how it will intelligently manage your resources. Why? Because it is happening through software level. So again, there is one more important thing how it got fixed. This next problem is, so as we have already discussed, so each operating system is consuming around 1 GB of RAM here. Here 1 GB RAM is there. Here 1 GB RAM is there. Here 1 GB RAM is there. So one thing we found out that we cannot change the hardware and wastage of huge resources, right? So here you can see here one operating system installed, here one operating system installed, here one operating system installed, here operating system is installed. So what happens is the intelligent way of these containers is these containers will not have any operating system. So you can say literally say that you can say that there will be no operating system. Okay, so these containers will run without operating system. Okay, just for your understanding, you keep it now. In the further classes, I'll explain how it exactly runs. Okay, no OS will be there. That means if you are giving this 4 GB of RAM, the complete 4 GB of RAM will be utilized by this container. Whereas here you can see, for example, I'll say we are giving this 4 GB of RAM. This 4 GB of RAM is not completely utilized. Out of that, 1 GB of RAM is utilized by the operating system, and remaining 3 GB of RAM is provided for your application. Whereas in case of containers, no operating system is there. If the container is asking for 4 GB of RAM, the 4 GB of RAM will be directly given. So there will be no wastage of any uh, hardware resource for the operating system. So that means 1 GB, 1 GB, and 1 GB. 3 GB of hardware resource is not getting wasted in case we are using this containers. Okay. So again, what happens is if here this virtual machines are fixed, right? So fix if this virtual machine is there, it will be taking your 2.5 GB directly. It will be always consuming this resource. If the VM is running, this RAM will be shared continuously. Whereas in this containers, what you can do is, for example, you don't have any work with this container 2. So what you can do is you can just simply delete your container. Okay, so again, if you want it back, you can just add the container back. Okay, so even if you delete the container also, there will be no impact, and whenever it is required, you can take it back, or else whenever it is not required, you can remove it. Okay, this is one more advantage of the containers. Okay, so what happens is, in the previous cases, what we have done is we are sharing our OS images, right? So we are sharing our OS images. So in containers, what we'll be doing is we'll be sharing Docker images. Okay, so here we are calling as VM images, whereas while working on these containers, we can call it as Docker image. Okay, so if you want to ship your this what we say here, I think I'll say Docker engine. Okay, so if you want to work on this is on this VMware. How we used to do, we'll be passing one image one, and we'll be shipping the passing the image to the testing team. Whereas in Docker engine, we'll be passing it as Docker images. Okay, and we'll be shipping it to the testing team. Okay, so again, you might be getting a little confusion. So sir, you are telling Docker images, but here you are telling it as containers. Okay, so containers is nothing but a machine. Okay, so containers, as I told, it as a virtual machine. So the content, it is a virtual machine. So Docker, this or else you can just containers. So VM is there. Okay, so this virtual machine, we are telling that the VM is available, right? So this VM, what we have done, we have taken one image copy, right? So that copy, if it is running, then it will be virtual machine. So similarly, here we are talking about images. So image is nothing but a copy. That means, for example, PUBG is there. So PUBG game, if it is, if you are downloading, so it is a copy. So that is nothing but image. So when you are running the PUBG game, so then it is called as container. Okay, so maybe you can, simple terms for your understanding, I can say the running form of image is nothing but container. Okay, when you run an image, that is container. In a simple terms, images are copy, that means a software copy. When you run these images, it will, these images will be running inside a container. Okay, so again, one more problem what we have solved is, it is very lightweight. So why it is lightweight? So as you know, a Windows operating system will at least have at least a minimum of 2 GB of uh, 2 GB of memory storage for running the operating system. So as you can see, as I told that this containers has no operating system, so that means 2 GB of storage is uh, saved, right? So in this way, it will reduce much time while shipping your package from one team to another team. Okay, so basically, in other terms, basically, and some people might also be calling this as microservices also. Microservices, why? Because it is very very lightweight and easily shipped to from one system to another system. Okay, so just this is what, just I'm just trying to make you understand how exactly this container concepts have been built. This is just nothing but a foundation for you guys, because when we are working on this practical part, you'll be able to know what exactly is a Docker, what exactly is a container, what exactly is this VM, what exactly is this VM image. So you need to have the foundation. So that is why I have told you. And also, I'm trying to explain this Docker because you need to understand the architecture in detail. Actually, I'll discuss with you guys this architecture also, but the main thing is the main structure of this Docker engine. How exactly is it different from this? Or else you can just compare like this. So you need to understand the difference between normal Docker engine and whereas this VMs. Okay, so this you can also you can create one more example. And this, what is that one more example is, you can just take the example of AWS. Okay, so this I have explained you regard, if you want to install on your personal computer. In your personal computer, you will install Windows, you will use this VMware software, and you will be creating virtual machines. This is in perspective of your local computer. In the similar way, this is also in perspective of your local computer. In your local computer, you will have hardware. In your hardware, you will be have, running one operating system, and on this operating system, you will be installing this Docker engine. Okay, so after this, when you install this Docker engine, you can be able to run this containers. Okay, inside these containers, you'll be having Docker images. Okay, for this uh, for the basics, you can just keep this in mind. And while we are working, we'll be coming with more and more examples, that in that time you'll be having more clarity. Okay, so here you might be asking, mostly this VM concept you can just correlate with example. I think again, if I try to explain, it will take much time. So the thing is, we are all working on AWS. So AWS, as I told you, this will be the hardware of the AWS. Simply you can say a data center. Okay, So when data center is there, for example, I will say this 1200 GB of RAM, because it is a data center. It might be it is a supercomputer. So one host OS it will be installed. So it might be a host Windows or Linux, whatever it is. It's their choice. So now what we are doing on this, we are going to this AWS, and we are asking it to create one instance for us, right? So this they won't be using this VMware, so they will be having this Zen or Nitro. Okay, so you might be asking, sir, what is this Zen and Nitro? So Zen or Nitro are this hypervisors which are built by AWS, right? So using this Zen or Nitro hypervisors, so it will be able to create your instance. So I'll change everything and I'll say simply EC2. I'll say EC2. Okay, 1 GB RAM. Okay, so this is how your AWS will be creating your instances. Similarly, here also the same. So I'll say EC2 2 GB RAM, just for your understanding purpose in how it is done in our AWS. Okay, so in AWS, as you know, it will have one huge data center, or maybe availability zone, or maybe regarding to the area, it will be having one huge hardware resource. So on this huge hardware resource, this AWS is will be running one operating system, and on this operating system, it will be installing one hypervisor. Okay, so the hypervisor it will be running, the name of the hypervisor is Zen or Nitro. Okay, then the user will come and ask for creating one instance. He will say, I need one instance with Linux operating system, and I need a 2 GB of RAM, and I need two CPUs, and I need 30 GB of storage. So then this Zen Nitro will create one instance, and it will be provided to the user, right? So this is how it will your AWS is working. Okay, so this is for the container section. So these containers will be working more. So again what happens is, for example, you have created one EC2. So inside this EC2, for example, uh, I am taking 8 GB of RAM. Okay, so again this 8 GB of RAM, it is virtually, that means you'll be having one computer. So again in this 8 GB of RAM, you can run all this. So hardware I got 8 GB. So inside this I will be installing some, because as you know this EC2 will be running on operating system. For example, it is running on Linux operating system. So what I will do is, I'll just take this section. What I will do in this 8 GB of RAM, I will install Docker engine. Okay, in this Docker engine, I will be running this containers. Right, we can say hypervisor and sub hypervisor. Inside the hypervisor, we are trying to create one more hypervisor. Okay, so that we can practically do. Okay, so this is just for your understanding and foundation purpose we have done. So so what we have, so I want just I want need you guys to explore few topics. So first you just understand what exactly is SDLC, then understand dev plus ops. Okay, so what exactly is that? And next try to understand what exactly is uh, virtualization. You can say, we can just find out these terms. And just hypervisor, try to understand. Then understand VMware, how it works, VMware, and architecture, and working. This you can this you can try to understand. And then the same thing, uh, we'll be working try to understand what uh, before this you need to understand how okay, VM images you can understand. And then disadvantages and problems you try to understand. Then you try to understand what are containers. Next, Docker engine. This actually this Docker engine and all we'll be exploring more and more. And Docker images and Docker hub. So Docker hub also you can just try to explore. And Docker architecture. Okay. So just you try to explore these points. Okay. So we'll discuss much more about this Docker and we'll start working on this. And also, if possible, what you can do is try to complete this. This will also save time some time. So you can also install Docker on your computers and keep it ready. Okay. So that will also help us to start in a very smooth manner. Okay, this all just explore. Just what I'm asking is after the class, because in a class we'll be having very limited time. We'll not be able to go much deeper and deeper. So after the class, because these are the some of the important points which you guys can explore and try to get more touch with the subject. So that is why I'm just giving you the key points. Using this key points, you just try to explore. Just search this on your Google and try to get deeper about it. Okay, if possible, you keep the installation. You can install Docker and keep it ready, or else we'll do that practically in our class. Okay. So this is actually mostly we have done with this theoretical part. So I think we can't take the theory for a very long time. Okay. So tomorrow we'll go further into this Docker and we'll try to complete the installation also, and then we can start with practical. Okay. And that is it for today's class. If you're having any doubts, I'll be here to clarify them. And the other guys, if you are having any work, you can just leave. Okay, I'll be available for clarifying your doubts.